All right, welcome back. Today we will be looking at special permissions. Then we learn how to use the set user ID command, the set group ID command, set facl, and stickybit. These are all important concepts we need to learn on how to set permissions. At the end of this class, I expect us to be able to know the need for special permissions and on how it helps us to gain fine-grained control over our directories and files, and also to be able to manage these permissions using the commands that we've set up here. Okay, at the end of the class, I also expect us to be able to be more security conscious on how to deal with files and directories. Before I continue, it is very important for me to remind you about our file permissions, how to understand file permissions. We said there are three modes. I mean, there are two modes: numeric mode and the symbolic mode. All right. So when we talk about symbolic mode, we are referring to alphabets, and there are three signs, which is the RWX, R for read, W for write, and X for execute. And for the numeric mode, there is the three numbers, 4, 2, 1. So 4 for read, write for as 2, and X for 1. When you add them together, we will have 7. We've discussed this in detail in our last class, so I would not elaborate more than this. If you're confused or do not have a good understanding on permissions, please go watch the last class. Thank you. So please go back, refer back to the last class and go through it. All right. So for those of us who are here for the first time, I'm currently running Ubuntu virtual machine on VirtualBox. This is where I'm going to be having my lab today. So I would click on start to get us started for today. Okay. So let's continue with this. All right. So what I did here was to delete the old user that I created on the system. And we did that in our last class, and I need to create something different in this class. So I've taken that off and clear the screen. So what we're gonna do here is to check the directories that we have, and here we can see the directory we created in our last class, and the directory was created in our last class. Probably we'll leave this as it is and create new ones. Okay, so I'll clear this also. All right, so let me create a new directory and say special perm. All right, this is going to be our special permission directory. So I will go into the directory, change directory to go inside. When I do ls, you can see it is empty. Our new directory is empty. Okay. So what happened here, I created a directory called special permissions, and I moved into the directory. Then I listed the files in directory. We do not have any file in our directory here. So what if you are working as a DevOps engineer and you needed to create a password.txt file, right? So of course, password.txt file are usually sensitive files, and you do not want your file to be accessible to everyone. So what are we going to do? So when I create, first of all, let's know who am I, which user is currently logged into this machine. I'm using the OS Boxes user. All right, so what I'm gonna do is to create the password.txt file. When I create it, it is created. I will list it. Use the ls-l for to have a long list. You can see it has a read write permission, and a read for others. Okay, don't forget this is the user OS boxes, and this is the group OS boxes. So what this means, if we are to use our numeric Linux file permission mode, so do not forget that we said 4 is read, 2 is write, and 1 is read, execute, right? So this is read write, 4 plus 2, 6, 4 plus 2, 6, and this is 4. So if I'm to give this permission using the normal Linux file permission, just like what we have here, if I'm to give you this, I'm defining this now, these numbers. Okay, for those of us who don't understand why we have 7777. So I created a file, I listed it, and this is the permission that I'm seeing on my file, right? So I'm giving you the numeric code for it. So 4 plus 2, 6, 6, and then 4. So if I'm to change the permission to give me this using my normal, using the timeline, that'll be 664, then the name of my file, right? Okay, but what if I do not want anybody, like I do not want the group, this is the group, to be able to write on my file or to be able to read the file, and I do not want anybody else to be able to read the file or write on the file or execute the file. All right. So, and I do not want anybody to be to write to execute on the file, which means I'm going to change all of these permissions in a way that nobody has access to to this password.txt file except the user. So how am I going to do that? So I'll say sudo change mode, because I know that this is my user, and my user has a read write permission. So I'm removing the write permission, which is a W, and I know read is 4. Read is 4. You can see here, read has its number is 4. So I'll say 4, which means my user can be able to read the file. Then for the group has a read write permission also. I would take it off. I do not want them to be able to read or write the file or execute it. So I'll say 0. Everyone else who is not in the group or who is not a user, they are able to read the file, but I do not want anybody to be able to read the file, because if they can read the file, definitely they have access to all the passwords of our users, and I do not want that. So I'll say 0. Then I will call the file that I need to change. You can see that now. So when I do ls-l, you can see that the permission has changed to just read for the user. So what this means is that the group and everyone else does not have access to my password.txt file. We can practice this. We can create a group, create a different user, and see if they can access this file. But it's going to make this class a bit longer than it should. You can practice it. You can practice this on your own. You can create a user. When you create a user, create a group, and try to see if they can read the file or they can write the file, execute the file. They won't even be able to access this file because they are not permitted to. Okay. What I'm gonna do is to just practice one of these. I think I have a user on the system already. So I'll say switch user. SU means switch user. So a switch user or you Gabriel. I'll put my password and I'm in. So now if I say who am I, you can see the person who's logged in now is Oyu Gabriel. So I will try to see if I can access this password.txt file because the permission says only the user and the user is OS boxes. Everybody else or anybody who is within the group cannot access the file. So in a real sense, if what I did is correct, Gabriel should not be able to access this password.txt file. So how am I going to check that? List the directories and files that are here. I can see it when I clear this. Say who am I again to be sure who am I? Oye Gabriel, and I do ls dash l, that dash l. So I can see the password.txt file. All right. So let me do cat password.txt. You see, you can see permission denied. I am not allowed to see the content of the file. So this is what I'm trying to make us understand. Okay, so now that we've done this, I will then go back to my user and say switch OS boxes, put in my user password. All right, so I'm back in now and I confirm who am I and I am OS boxes. I clear back the screen. The next thing I'm going to do is to change the group ownership of the file. So to change the group ownership of the file, I'll use the command sudo change group. I'm going to give it, first of all, I have to create the group before I can change the group. And I would look into to see the group that I have saved from my previous class within the system. So before we change the group, let's view the just a group. Yeah. So let's see the groups that we have. So we have a group here called marketing. All right. Another way to view a group is to say get entry group. You can see our group marketing. All right. So there are various ways to get this done. Okay, so let's proceed to change our file.txt. So this is our group. Let's change the file.txt. Let's change the group. To do that, we say sudo change group, password.txt. Okay, missing operand password.txt. Okay, missing operand after password. Okay, sorry, I didn't put the name of the group we want to change it to. So the name of the group says marketing. All right, so that has changed. I'll clear this now and I'll check the file again and see. All right, so we see we have a group called marketing. So we've changed the group for our file name, but still anybody who is in this group cannot still access the file because they do not have any permission to view the file. But I just did this just for us to see, to refresh our mind on how to change groups, like what we discussed in our previous class. Okay, so let's get down to the main purpose of today's class. That is how to how to um, set user ID, set group ID, and sticky bit, right? Sticky bit. Okay, so for set user ID, what this means is that you can run the file with the user's privilege. For example, you can see the password.txt file, right? And this is the user. So what if a different user called Gabriel or a different user called James wants to access this password.txt file and want to be able to run it? So what set user ID means is James, which is a different user who who is not the owner of this file password.txt. Set user ID gives James the same privilege as the owner of the file OS boxes. So rather than changing the owner of this file or changing the permission of this file, you can just say set user ID. So it gives James access to this file the same way OS boxes, that is the owner of the file. In a more simple terms, in a more simple term, set user ID gives anybody who runs this command the privilege, the same privilege as the owner of the file. Okay, we would see how that works. The same thing applies to set group ID if this is for user and this is for group. Okay, then stickybit, what stickybit means is users can only delete their own file. For example, we have a directory called special permissions. If we have different file here, like our password.txt file, and which is owned by OS boxes, if the user James wants to delete this file called password.txt, he will not be able to because there is a sticky bit attached to this file. So how do you know there is a sticky bit attached to a file? When you run ls-l, you would always see the alphabet T somewhere within the permissions of that file. And how do you know if there is a set group ID or set user ID when you run ls-l on any file? You would see the alphabet S to tell you that there is a set user ID permission for that particular file. Okay, so don't forget, set group ID and set user ID uses the S letter for its permissions, and sticky bit uses the alphabet T for its permissions. So let's clear this and set a new permission. First of all, I'm going to create a new file called touch file, say special perm.sh. This is a sh is a search is an sh sorry it's a shell script file, which means you can run this as a script. All right, so I have my, let me check for it. Okay, so I have my file now created. So what I'm going to do now is to check the permission of the file that I've just created. This is my new file. You can see the file that we created. This is the user of the file. This is the user or the owner of the file. And this is the group that owns the file. Okay. All right. So we can see over here that you can see here that the user or the owner have a read write permission. The group has a read write permission. and the everyone else who is not the owner and who is not in the group has only read permission. All right, so we are going to change this permission with using our set user ID command. Let me clear this. Okay, don't forget we have two ways to set permissions. We have the numeric and we have the symbolic way of setting permissions. All right, when you do ls-l, what you see here is the symbolic way, which is the read, write, execute, which is, or call it the letter mode or the alphabet mode. Read, write, execute. That is it, like the symbolic mode. All right, so I'm going to change our file special permission.sh, and I will change the permission to have full permission. So all of this will change except this last one. Of in our last class, we said the first permission, the first item on this list is usually the file type. So you can see there's a dash here. So a dash tells you it's a file type. When you create a directory, this gives you D. So D is for directory. That's always the first item when you looking for your permissions. Okay, so it gives you the file type and the permission that is that the file has. All right, so I expect from here, from the arrow all the way down, for it to change, the full permission should be rwx, which is read, write, execute. So I'll change the permission for special.sh. All right, so I'll use sudo change mode 777. This is numeric mode of changing permission. If I want to use the symbolic mode, I will say read, write, execute. All right. Don't forget, read is 4, write is 2, and execute is 1. So that is 4 plus 2 plus 1, 7. So I'm giving you 4 permissions: read, write, execute, read, write, execute, read, write, execute, for both user, both group, and others. All right. So special permission that sh. Click on enter. Click on my sudo password. All right. So I'm in now. When I do ls-l, you can see I have full permission for my file called special permission.sh. All right, so I'm going to clear this, and we are going to use our set user ID now to change to see how this works. You can see here we only have read rwx, read, write, execute for user, read, write, execute for the group, read, write, execute for everyone else who accesses this file. All right, so let's change the set. Let's create set user ID for this file. Set user ID, don't forget that your set user ID gives anyone who runs this file to be able to run this file as if they are the owner of the file. All right, so like I said, we have two ways to set permissions. We have the numeric way. So to use the numeric way, the numeric number 4 is the number for set user ID. So, and I will say 777, leave it as a full permission, and I will call my file name. All right, so I have given it set user ID. You can see that we have an extra permission for the owner. Don't forget the first 3 is the owner. You can see that instead of X, we now have S as the permission. So this means that there's a set user ID for this file. Anybody who accesses this file or who runs this file will run it with a special privilege as the same as the owner of the file, as if they are the owner of the file. So this is the same as when you run group permission. For example, for set group ID, the number is 2. For set user ID, the number is 4. All right, that the numeric number is 4. But this the symbolic number is S for both of them, for both um, for both user ID and group ID. So S and S, symbolic way. So to change to S, so even though because I already run my set user ID here, and I've changed it, the permission to give me S here, even if I run the set group ID, it it would move my S to the group aspect of my permission. All right, so let me do that. You can see here I only have my set user ID for my user or the owner, but just none for the group. All right, so let me set for the group and say sudo. Okay, I can send for sudo. It says change mode to 777 special permission. All right, so when I do ls-l, you can see that I now have my set group ID, which means anybody who runs this file will run it as if they are part of the group. Okay, so let's clear this. If you need more explanation, please do not forget to research. So how do we take off this our set user ID and set group ID? The same way we do that, I would say change mode 0777 and the name of my file. When I do ls-l, you can see that it is gone. I'm back with my execute permission. So it is gone. Okay, it is gone. You can also see that both for the group and the user, there is no special permission on it anymore. It's back to the default, right? Read, write, execute permissions. Okay, so how do you create this without using the numeric way to do the same thing? It's a change mode, set user ID, right? So user ID plus S. So I'm giving it the sticky, the set user ID S for the user. Say permission. So I'm just showing you different ways to do this. The first one I used numeric way, which is numbers. Now I'm using symbolic way, which is my letters. Okay, so when I do ls-l, you can see that my permission is back, same way we did in the previous one. And when I say smod group add s on the same file, and I do ls-l, you can see that my permission is also back for the group and also back for the user. All right, so I'll clear this and I'm going to take off the permission. So in the first one, we added 0, 777, 0, and the permission that we wanted to have. But now I'm going to, instead of using numbers, I'll just say the user minus. I'll use minus and take off the permission and the name of my file. Click on enter. When I check again, I can see that it is all gone for the user. And now we have to take off for the group because the group is still there. You can see that when I did smod 0777, it took out for both the group and the user. But this is more specific. It tells it I want only for the user, and that is what it did. All right, so let's take away for the group. This is not my file. All right, so let's check. You can see that we have our permission back 777 read write execute for everyone. Okay, so that is it for set user ID and set group ID. Helps you to set owner privileges to a particular file. So you have to be careful when you use set user ID, because you are more like giving them a root privilege, and you do not want that to happen, because when you misconfigure a set user ID, they can when you misconfigure a set user ID for a sensitive file to the wrong person, they can steal important information. So this is quite tricky. So be careful on how you give permissions. All right. So the next thing we are going to do is to do stickybit. So stickybit is just don't forget that stickybit permission is T. The symbolic permission is T. The set user ID and set group ID that we did earlier was S. All right. So the numeric number for stickybit is 1. All right, so to do that for our some file for our stickybit, I would say 1777. Okay, so what is going to happen is to make us understand what stickybit is. Stickybit. All right, so when you have a directory, for example, a directory called marketing department, don't forget directory means folder. Now, in within our marketing department, we have different users who have access to this file called marketing. So we have users like James, John, Eva, and and um, and every other person who was within the company. They have access to this file. So what stickybit does is it prevents Eva, John, and James to accidentally delete a file within our marketing directory. For example, if James created a file called sales.pdf, Eva will not be able to delete the file. John will not be able to delete the file because they are not the owner of the file. So this is what stickybit does. So it adds more protection to the files within a directory. I hope that is well understood. All right, so let's first of all, before we do that, let's create a directory and say sticky directory. Let's check on that. So we have a directory called sticky directory. All right, so let's check the privileges of our sticky directory, the permissions rather. You can see the directories, the permissions that our directory have. You can see here that the first item here is D, so D is for directory. Okay, so this is the owner of the directory, and this is the group that the directory belongs to, and these are all the permissions. All right, so this means that the owner has a read write execute, the group has a read write execute, and the everyone else who is not part of the group and who is not the owner can only read and execute within the directory. Okay, so what we are going to do is to add a sticky bit to this directory called sticky directory. This command here, ls-ld, list What it means is to list, or is to list the directory without without giving me the content of the directory. That's why you can see here it has a dot. I can as well say ls-l. It's still the same thing. I can still see everything that I want to. All right. Okay, so let's add stickybit to our directory. First of all, let me list it again so we can see the default directory, default permissions that it has. Sorry. All right, so let's add stickybit and say change mode. Stickybit has a number of one, so 777. We are giving it full permission. So stickybit is one for stickybit one for the directory, and full permission read write execute for the user, read write execute for the group, read write execute for everyone else who can access the file. Okay, so let's put the directory name. We have it there, and we click enter. Then we ls to view, and we see that there's a T attached to the permissions of our directory, which means anyone who is not anyone who has access to the directory cannot delete anything within the directory. They cannot delete, they cannot move, they cannot rename any file within the directory that they did not create for them. I mean, that they did not create. So it helps to, this is very, very important when you have like a temporary directory where everybody has access to. Now, think of this as a common room, like a lounge where everybody has access to. Okay, people can easily steal each other's item, right? So it is good to have like a cabinet where every person has their name on their locker. They can lock their valuables. So each locker has the user's name, right? So when you have your key and you need to close for work, you can open your locker, get your phone, your items, and your car keys, and go home. Okay, so it gives you a bit of privacy for your items. So this is what stickybit does. So it gives every user who accesses this directory a special privacy in a way that any file that they create cannot be edited and cannot be renamed. You can see that it is highlighted. So if I, for example, switch user and say, oh, you're Gabriel, and I try to go into the stickybit directory. Okay, there's no, we do not have any file within the directory, so there's no point. I think I put the wrong password. Okay. All right, so let me clear. All right, so let me move into my stickybit directory and let me create a file, say touch, and say create a file called don't delete .txt. All right, ls. All right, so the owner of the file is OS boxes. All right, and it says don't delete. So let me add stickybit to. All right, so the directory has a stickybit already. So let me switch user now and see if this user can be able to delete this file. Okay, so I'm in. Say who am I as a user. So the user now can list the file. God says don't delete. So let's try to delete the file. Say remove, don't delete. Say remove, Okay, let's see. You can see that the file is still there, even though we try to delete it. So let's try again. Don't delete. Let's say yes. You can see operation not permitted. It just stopped the user from deleting it because they are not the one who created the file. This is a very interesting concept. All right, so let's move forward to a different permission. So we have what we call umask. All right, umask. All right, so we are going to do this last. Let me just move to setfacl. All right, so let's talk about setfacl. To know, okay, so let me switch back to my normal user. Okay, I'm in now, I guess. Who am I? All right, so let me go off this stickybit directory. Okay, so I'm back to my special permissions directory. All right, so let me clear this here. All right, so first of all, what is setfacl? Setfacl is just for you to set access control for a file. So to do that, we use the setfacl. Setfacl means set file access control. Okay, so to continue, we need to refresh our mind on permissions again. Don't forget we have 3 rwx equals 7. Okay, that is read permission. Because why? Because r equals 4. Sorry, r equals 4. Yeah, r equals 4 and w equals 2 and 1 equals, sorry, x equals 1. So 4 plus 2 plus 1 will give you 7. So when a user has a read write execute permission, they have the number 7 because they all have this 4 plus 2 plus 1 read write execute. All right, so if you want to give only read permission, then it is just 4. You want to give only write permission, then it is just 2. You want to give only execute permission, then it is just 1. If you want to give a read write permission, it will now be 6. Oh, this is understandable. I'm just refreshing our minds. Okay, so to say to before we do set our ACL, we can say get ACL for a file called. Sorry, let me check the files that we have here. So we have special and we have password. Okay, so let me get file ACL for special permission. We can see that the the name of our file is special. The owner is OS boxes. The group is OS boxes. The user has a read write execute permission. The group has a read write execute permission, and the others also have a read write execute permission. Okay, so we are going to change this permission. Another way to check this is just to do ls-l. Okay, you will see everything that you see. I can see our special permission file. This is the user and has a read write execute, same way it is here. You can see the group has a read write execute permission, same way with the group here, and the everyone else, which is others, has a read write execute permission. So you can use this command or you can use this command to view your permissions. Okay, so let's set the permission. Let's set permission. using setfacl SEL. So now use the word modify. So modify our user. Our user is OS process. Let's give it a read permission for our special .sh. So what this means is now this user for this particular file, this user if currently has a read write execute permission, and now we are giving it only read permission. So W and X will be taken off, and they would only have a read write permission, which is R. Okay, so let's run this command. This is the permission R. Is the permission we're giving it. The user, the user that we are giving it to is OS bosses, because that is the user who currently owns the file. And M here is to says to modify the file. So I'll click enter, and then we do ls-l again. You can see that it is added. A new plus sign is added for special.sh. Okay, sorry. What this does is it gives a special permission to a user, even if they are not the owner of the file. So we need to change this to a different user so that we can properly practice this permission. Okay, so before I do that, I will then have to, let me clear this, call back the command, okay, change it and give it a different user. Click on enter, ls-l. You can see that our user is going to have, you can see that the user didn't change, but our user is going to have a read write permission. So let's do get facl special. You can see that there is a mask permission there for read write execute. You can see that an additional user has been added. User was, this is the one we created for the first command that we created before we did the second user. So the reason why I had to redo this is because OS boxes here, this user already have a full permission. They are the owner of the file, and I know that. So I had to create a new user. I had to give it a new permission with a different user, which is Oyugebra. And you can see that Oyugebra has a special permission to be able to read the file. Okay, so we can also give this user more privilege. Let's see if this works. Give it read write execute permission. Okay, it worked. So let's clear, do getfacl for special.sh. You can see that our new user can also read write execute, can read write execute on the file special.sh, even though this didn't change within our permission here. So these are special permission that has been given to this, that was given on that file for a different user. I hope this is understood. If you are confused in any way, feel free to leave a comment or reach out to me. I will explain to you in a much more clearer term if this is not clear enough for you. Just leave your question behind with me, and we will sort it out. All right, so the final one that we are going to look at today, let me clear this, is umask. So umask is simply to take out the permission that you've already given to a particular user. So we have a user here called OS boxes. So we want to give it, take some privileges away from the user. So we use umask. So it helps to control the default permissions that are given for newly created files. Okay. Okay. Let me just do this for you to understand something. All right. So you can see this here, mask. Mask says read, write, execute. So this is the default permission that has been set for this particular file. So a umask is to a user mask is to set a kind of default permission that should be given to a particular file when it is created. So when I run this umask 027, it is saying that the zero, this is umask actually takes a permission. All right. For example, you can see. Okay. Let me create a different file and say touch umask file.txt. Okay, we have a new file. Let's check the file. Let's check its permissions. Our umask file.txt has only read write execute for the user and the group, and only read for everyone else. So let's change that. So let's give it full permission for everybody. Change mode 777 umask file.txt, and let's check again. You can see that everybody now has a read write execute for this particular file. Okay, so if we want to set the default permission that should be given to a particular file when it is created, we use umask. Okay, so when we did touch umask, right, to create a new file, when we listed it, it had this default permission: write, um, read write, and a read permission. So the if I am to put this in a numeric way for the user has a read write execute. So read is 4 and write is 2, that is 6. So for the group, also read write, which is also 6. And for everyone else, it gave it only read, which is 4, that is 6. 6 is 4, right? So this is the default permission that my system currently has when I create a file. All right, so I'm going to change this default 664 permission for my system and give it a different permission, uh, a different default permission. So if to do that, I'll say umask 0. 0 means full privilege. Then 2 and 7. So what this means is my system currently has a write permission as default. So don't forget that for W, which is write, is 2. So it is taking away 2 for the group. You can see that it's taking away 2 for the group. And okay, let me delete this since I've not done it yet. So let me come again for clarity. The first thing I'm going to write here, this is my user. My user currently has read, write, execute. Read, write, right? So, which is 6. I'm not going to change their permission, so I will leave it at 0. For my group, the group currently has read write. I do not want them to have write permission, so I'm going to remove two. Two is write, and W is two. Four, don't forget four to one. Four for read, two for write, and one for execute. So I'm removing write permission, and the numeric code for write for write is two, and my group currently has permission R. I did not want them to have any permission at all. So I'll put 7, which means take away read, write, execute permission from anyone else who is not a user and who is not in the group. So when I click enter, that is done. When I try to create a new file now and say umask testing.txt, click on enter and we try to view the file. You can see here that okay, this is quite different. I'm still having read write, which is read write, and I'm seeing here read for only my group. Okay, something is not right. Let me. Yeah, I think you are right. I think what we did is correct because we did not remove any permission, so the permissions still remain intact. Sorry, what is it? What is it? What is it? What is it? Yeah, so our permission still remained in. Let me. Okay, I'm confused here now. Okay, let me clear this. I'm seeing too many letters and it's confusing my eyes. So that is cleared. First of all, let's check the mask values for that our system currently has, so we don't make any mistakes again. All right, so our system currently has 0027. Okay, so we can see here 0 to 7, which is my default permissions, which means what we did previously was correct. The whole the whole too many detail in the system was a bit confusing. So this is my default permission. The extra 0 here is for special bits, sticky bit, set user ID, and all of that. So it's mostly 0 anyways. So this is what we are mostly concerned about, 0 to 7, which we had set earlier. So what this means is that for our directories or folders, they have permissions as 777, and for our files, they will have permissions as 666. Okay, so 666 means they have read write permission, read write permission, read write permission. This is for the user, for the group, and for everyone else. So user, second 6 for the group, the third 6 for everyone else. Okay, same thing for the directory. So when we had our umask of 0 to 7, it is going to take out, because 2 is right? So to take out right, and 7 is read write execute. So it will take out everything for the, oh man. Okay, so take out everything for the user and it will leave it with nothing. So the file that I created earlier should have this permission. Let's confirm that. So read write for the user, read for the group, and nothing for everyone else. Let's confirm. Let's confirm. ls-l. This is the file that we created earlier. And yeah, okay, so we are correct. So it had a read write permission for the user, only read permission for the group, and nothing for the for everyone else who accessed the file. Okay, so this is how umask work. It changes the default permission for a new created file. So any other file that we create is going to have this permission. So it helps to, so this umask is very important in a way that instead of you to consistently, maybe you are the admin, you are the server admin, or this, or the senior developer, and you, instead of you to continuously having to change permission for everyone who access the server or who access the system, you just use umask in a way that whenever a file is created within the group or within the system, there is a default permission that is given to that particular file. We would see a bit more detail in this when our in our project lab. There will be a project lab, a take-home task for this. But then when you practice it, you would have much more deeper understanding of what we are trying to talk about here. We've explained lots of interesting concepts, and I want to believe in a way you've gained something, you've understood something. If you have any question or you are concerned about a particular thing that is not clear for you, I am much more available. Reach out to me, make a comment, and I will respond to you respectively. Thank you. Live long and prosper.